Welcome. From nuclear physics, we are discussing about the radioactivity. In this lecture, we have to see a radioactive series. In previous lecture, we discussed about the carbon dating or archaeological time scale, which is used to measure the age of fossil or the age of a dead animal. We know that when we take a food or we take a breath, we take carbon 14 with carbon 12. The carbon 14 is a radioactive, carbon 12 is not so. In case of the living organism, the ratio of this carbon 14 to carbon 12 is a constant. When the animal is a dead, then the carbon 14 is a radioactive, so it decay the beta particle. So the ratio of carbon 14 to carbon 12 is a change, and by calculating this ratio we can find the archaeological time scale or the uh, age of any fossil. Friends, in this lecture we have to see what are the different radioactive series. After attending this lecture, student will understand the different radioactive series. That is a 4n series, then 4n plus 1 series, 4n plus 2 series, and a 4n plus 3 series. So we have to see one by one. We know that there is a disintegration of a radioactive elements. The element which have atomic number greater than 83 have unstable nuclei. So it emits alpha particle, beta particle or gamma radiation. The element which emits or a disintegration of the element is carried out, it is known as a parent. When this integration is carried out, we get a new parent, or simply we can say that the parent is converted into the daughter. This parent daughter formation process is a continuous. Through uh, finally the end product is stable nuclei. The end product of this radioactive series is a stable nuclei. So first member of the series is called as a parent. Immediate member are called daughter. And the final stable member is called end product. If you consider A is one of the radioactive elements, this is known as a parent. The decay of alpha particle and beta particles is carried out so that we get a element B, which is also radioactive, known as a daughter. The disintegration of daughter is also carried out up to the end product, or simply we get E, uh, E element, which is a stable element, and it is an end product. When the naturally occurring radioactive isotopes are studied, scientists found that they could be divided into four series. The four series are: first is a uranium. The series are named according to their parent atom. That is, parent is uranium, then actinium, thorium, neptunium, and these are the different series, and these are the parent atom. Now, each series consists of a successive of daughter element derived from single parent. We know that when there is a emission of a alpha particle, the atomic number is decreased by 2, while mass number is decreased by 4. When there is an emission of a beta particle, atomic number remains same, but mass number is increased by 1. While there is an emission of a gamma rays, the atomic number and mass number are unchanged. So here, when uranium is a decay, that is a decay of a alpha particle, its mass number is decreased by 4, and therefore the first series is a 4n series, where n is any integer. All nuclide, those whose mass number obey the equation A is equal to 4, that is the mass number is equal to 4n, are said to be the member of this 4n series. The nucleides whose mass number obey the relation A is equal to 4n plus 1 belonging to 4n plus 1 series, and similarly there are 4n plus 2 and 4n plus 3 series. Now we have to see one by one. 4n series. Okay. The thorium series is a 4n series in which the parent atom is a thorium 232. Okay. The half-life of the thorium is 1.39 into 10 raised to 10 years. Okay. That is a time required to disintegrate half of its original value. The series is a thorium series. The mass, or we can say that 4n series, and the end product, that is a stable end product, which is not radioactive, is a lead 208. Now 4n plus 1 series. 4n series means thorium emits beta particle. Okay. Extremely sorry, alpha particle. Okay. 4n plus 1 series is a neptunium series in which the parent is a neptunium 237. The half-life is a 2.25 into 10 raised to 6 years, and the end product is a stable end product, that is a bismuth 209. Third series is a 4n plus 2 series in which the series is known as a uranium series, in which the parent atom is a uranium 238. Half-life is a 4.51 into 10 raised to 9 years, and the stable end product is a lead 206. So this series is a 4n plus 2 series, that is a uranium series. Then next series is actinium series, or 4n plus 3 series, in which the parent atom is a uranium 235. Half-life is 7.07 into 10 raised to 8 years, and the end product is a lead 207. So these are the 3 series. So in this lecture we discuss 4n series, 4n plus 1 series, 4n plus 2 series, okay, 4n plus 3 series. Because if we consider the thorium series, it emits alpha particle, so this is the 4n series. or the element which are having the mass number is A is equal to 4n, okay, where n is the integer, is the 4n series. The end product of this series is a stable end product, okay, which is a lead. Then the second series is a 4n plus 1 series. Third series is a 4n plus 2 series. 4 then next series, fourth series is the 4n plus 3 series. So these are the different series. That is thorium, then the neptunium, then the actinium, uranium. These are the different series. The end product of all these series is a stable nucleides. So this is related to uh, different series. After this lecture, or in next lecture, we have to see artificially produce radionuclides. Thank you.